Okay. Switch. Here we are. Okay. So good evening, everyone. So I'm Cedrick Lunven. I work at DataStax. And as you might tell, I'm French with my ugly accent. So pay attention or you won't understand anything. So who among you are already familiar with Apache Cassandra? Oh, not that many. That's great. You're in the same place. Most of the time, half of the room just say, we know Apache Cassandra. So I ask the second question, who know why it has been called Cassandra? And nobody's know. Well, Cassandra has been created 10 years ago by 2 engineers at Facebook. And they chose Cassandra because Cassandra used to be in the Greek mythology, used to be the daughter of Priam, king of Troy. And Apollo, god of beauty, fell in love with Cassandra. So he gave her a gift, a power. She was able to see in the future. That's great. But Cassandra didn't love him. And so as a god, he cannot unmake what he made. So he had to change it. And so now Cassandra can see the future, but nobody trusts her. This is what we call the curse of the oracle. Okay, you got it. Okay, so as I said, I'm developer advocate at DataStax, so I tend to create tons of content for you to learn and succeed about Apache Cassandra. I will show you a ton of links and QR code and things in the end for you to take pictures. So this is my life during day, and during night, I'm an open source developer. I created 6 years ago a Java framework named FF4J, Feature Flipping for Java, which allow you to enable and disable part of your application at runtime without restarting it. So you deploy, open new features for beta tester, new tester only, and if it's OK, just push a button and everything got the new features. And if it doesn't work, it never happened, but if it doesn't work, you can just push again the button and there is no rollback. New features are just disabled. Other project I'm contributing is JHipster, which is a scaffolding application. Just provide your entities, and I will generate for you a full working application with front-end of your choice. Could be reactive, Angular, Vue, and in the back-end, it just Spring Boot. So in the talk today, I will show a bit of Java code. Don't be afraid. If you like Java code, you're in the good room. And so let's go. So reminders and learning about Apache Cassandra. Well, if you cross somebody in the street and that asks you, what is Apache Cassandra? Yes, you can say it's a NoSQL database created 10 years ago. It's colon-oriented. Nobody cares. Cassandra is a distributed database. And in the distributed, with multiple nodes. On each node, you can go up to 1 terabyte of data. On each node, you can go to 3,000 transactions per second and per core. Everybody does understand it. So it's distributed. That circle is called a ring or a data center. But in practice, all nodes just communicated all together. This is what we call gossiping. So what about those nodes? Well, you get the metrics. 1 terabyte, 3,000 transactions per second. If you need more power, just add new nodes. If you need more volume, just add new nodes. And that's it. This is quite the only database that scales linearly with the volume and the throughput. So you can scale. Oh, this is one ring, one data center, but you can also scale with multiple data centers. 1, 2, 3. They all communicate together the same way as a ring. And all that, it is what we call a cluster. Okay? And you can read and you can write in any of the nodes. if you change something somewhere, it will be replicated all over the cluster. So, for instance, let's say you're new banking and would like to do some tunable consistency. That Cassandra seems to be a good candidate. And on which database will you store your transaction or data? Well, if you stick in AWS, maybe you will choose anything like DynamoDB. But with Cassandra, you can install the same technology in multiple places. Can be any cloud provider, can be private cloud, can be on-premise. And those things communicate. You can have application running in the cloud, working with the data center locally, just to limit the latencies. And you can have some applications on-premise working with their ring, and data is replicated for you. There is no copy, there is no things to do. It's all done by the database. Okay, data is distributed, so it's sharded. That means you have a chunk of data on each of the nodes, like that. In reality, it's a bit more complex than just simple. But important thing is, I would like to connect to Cassandra, any of the nodes that don't care, and I would like to write new data. I provide the primary key is hashed. I'm going the fast thing. This is the fast way. So the key is hashed. With this hashing, I already know on each node copy that data, and that data will hold on that node. Okay. But data is also replicated. So the same data is not only located in a single node, but 2 nodes, and what we do most of the time is 3 nodes, replication factor 3. That means, look at that. You can lose any of the node. It's not a big deal. If I lose that node, I still have 2 copies of the data. It's extremely resilient. And this is one of the reasons Facebook just created that database at the first place, because in the cloud, things breaks. You are not you do not mastering the network, the disk, the latencies, and they are working on community aware, so it breaks. And using that, you are extremely resilient. Last but not least, you are querying your database. You would like to have a value. You know the value is available on 3 nodes, so you contact any of the node. Just provide the select. He knows the key to fetch. It will access each of the node, and when you query the database, you can say, I want only 1 node to give me an answer. This is the fastest way to process. You don't have to need strong consistency. So CL1 for consistency level 1. But you can also say quorum. That means I would like to have the majority of my node to answer and provide me the result, and then I get the latest. Every data I timestamp it, so I will get the latest. Or I can select all, but never do that, because you will lose any benefit of the high availability. And so in 5 minutes then, if you would like to ask why should I use Cassandra, this is the slide. The only text you will see maybe in the presentation. So high throughput, high volume, high availability, data distribution. Data distribution, you can have some customer repository that must be available both in US and EMEA, let's say global company, Uber, Netflix, Apple, they're all using massively Cassandra, not only because they have huge throughput, but also because they need the data to be distributed all over the world. And remember, if I change something in a node, in a data center, it will be replicated everywhere in two ways. There is no master and slaves. It's masterless. You can lose any of the node. And it is one of the great strengths of Cassandra here. OK, so now let's discuss about reactive programming, maybe. So I will maybe sit. So, okay, I will go past here. Okay, maybe first, so I will show you an applications, running applications. First version is full synchronous. Cassandra driver is run by DataStax. Well, it's not a commercial talk, as you may notice. There is no Shin commercial about what I said. But all the drivers from Cassandra, including OSS driver, has been written by DataStax for years now. The application is written in Java using Spring and Spring Boot and exposing an API in REST. And we are testing the application using JUnit. Okay. Okay, I need to escape here. Go here and show you some code. Okay, so is it big enough? Okay. So I have written the very same applications in 3 modes: synchronous, asynchronous, and reactive. And I will provide you everything to run that on your laptop, all the source code, all the Docker container to have both Cassandra and a notebook. So everything I'm doing here, you can do that by just cloning the repo. So first, this is just initializing the sessions, so nothing fancy about it. And I created a repo where I just implemented a CRUD function. And the interesting thing is here, find old symbol. So I have a table in Cassandra with that stores some. Let me show you what it looks like. So I have a stocks table storing some stocks, of course, with a symbol, a value, and a date. And I've created an API to be able to insert some stock, read, search, and get some info about it. And you see that in synchronous, well, it's really easy. You just execute, get a result set exactly like the things you are doing in RDBMS, get an iterator of that result set, and, well, just provide the answer. But okay, I saw before that there are some ops and AI guys, so I get pretty fast on the code. This is pretty interesting. So with Cassandra, when you initialize a connection, it's always synchronous. You will get a builder that will provide you metadata and then a session, and you should always initialize your statement when you start. You will compile your statement, compile your query from a simple statement to a prepared statement. When the statements are prepared, well, on the server side, you got an ID, and now every time I will query Cassandra, I will only provide the ID. There is no need to compile the query anymore. Anyway, there is no query plan, stuff like that. It's not complex at all. See in the architecture get diagram before? A query came, one node took the query and asked the correct nodes to answer because it knows on which server all the data. Okay, so first connection, then statements. And now you are doing some queries. You provide parameters. Parameters are linked to the prepared statement. They are bounded to get the bound statements, and then you get the result set, and you pass the result, and you're happy with that. And if you need to query thousands and thousands of records, well, it might be a bit slow because you are waiting during all that time. And even if the data are paged, that means in the first time you will have only 5,000 records. Well, if you say select star for my table, well, best case scenario, you blow on one node. Because that node will get all the data from the table, from all the server on a single place in the memory just to give you the answer, the response of your request. And the worst case scenario, well, the node has more memory than you, so you will blow out because you don't have any memory to hold that number of record. So in a nutshell, SWOT analysis about the synchronous, and this is what we all do all the time. It's simple, very easy to test. You can use browser, a simple web browser. REST API are very easy to test anyway. But it's blocking. It's blocking, and when it's blocked, it can block all the resource on your machine, and you cannot scale as much as you would like. You can still horizontally scale, but not vertically. So with asynchronous, second part of my demo, I kept the exact same stack because yes, REST is asynchronous now. Don't know if you know, but for a couple of years already, like 5 to 10 years already in the standard, REST can be asynchronous, and you don't have to wait all the HTTP thread to get the answer. Okay, so now if I go to the code, yes. If I go to the async code, you have, okay. Can I put that bigger? Okay. You still have the bind, okay, nothing fancy about that. But you do not get the result when you execute the query. You get a complication stage. And only then you will say, then compose, okay, I let you work asynchronously, and when you are okay, when you completed, then I will compose and run the second part of my algorithm also in synchronous manner. And in the end, I still have a third things to do. But if let's say I would like my record from 10 to 15, and everything is done asynchronously, at a point of time, well, I need to count to be sure to be 10 to 15. There is no paging as I used to have. And so for the row collector, I need to implement my whole algorithms. And so when I get my result in asynchronous manner, I need to compute and get the offset and the limit until I reach my thresholds, and then I'm complete, I'm okay. So you can see, even need to do a simple select X from a table, then you get hundreds of lines of code. So it will work, it will be faster, because now you don't have to wait, you get a completable future. But here you can see immediately what the issue is. Okay. Parameter came, get the prepare statement, bind the parameter, bind statement, boom, get the complication stage. And only once ready, get the async result set. 3 hours to make the slide. Okay, you're awake. Okay, but still, as I show you in the code, this is really a callback else. So before in the evening, we saw that the banking were using asynchronous all over the place, which can gain you tons of value and performance because you don't have to wait the answer, and you maximize the use of CPU and nothing is blocking. But when you need to handle the different use case, paging, error, it becomes some callback hell. And I only show you one part of the code. Imagine now you get 3 completable features, and if the first is succeed, I got my code. If the first is wrong, I got another code. And then if the second is false, then I have a bunch of code, and so forth and so on. So you get a tree of all use case to test to be able to be sure that your code won't fail, actually. And so asynchronous is not blocking. Yeah, that's fine. You can scale. Again, that's OK. But what about the callback L? And what about maintainability? If you already work with asynchronous code, I don't know if you already did, but it's pretty hard to do some breakpoint. You cannot say, oh, I'm already there, I need to wait there. Everything doing his work on his side. And if somebody's not ready, there is a timeout. So you got a hard time, very hard time to test and to do the maintainability of the asynchronous code. And so this is the reason why few vendors signed the Reactive Manifesto, which is some way to do some asynchronous in the good way, in the simple way. It's all message driven, and the whole purpose of it is to be resilient and elastic, using a small portion of code, small threads, small component to be able to lose one of those components and still going. Elastic to be able to add a lot of resources, add a lot of the same component multiple times. Yeah, just to be able to maximize the use of your resources and still keep simple. And what it does is actually a bit like some queuing. You will subscribe. So here, it's like I will subscribe to a table. And each time I will get a new record in that table, I will get notified and get my new things. Those are the framework, the mostly known to implement that reactive pattern. But each time there is a new record, you get notified. It's not forever. It's not an infinite loop. It just say, I'm subscribed, I do select star, and for each record, I will get a notification, and when it's done, I will get a non-complete. So if you have a nice JavaScript front end, it's pretty easy to just have the query running again and get real-time curves be drawing. For each new item in the tables, you will get notified and get the curves that keep drawing. Okay, in my small demo, I need to change the way REST is exposed, because when you implement some reactive programming in a Spring application, everything must be reactive. It's now forbidden to have any blocking part, any blocking code in your applications, and such, even the API. And this is the reason why in Spring Boot 2.1, using Spring WebFlux, now we are able to expose some fully asynchronous API and do all the stuff. So let's write some awesome code now. Here it is. And so if I go to the reactive stack now and go to the very same find all method, now it's no more a completion state. It's what we call the flux. As its state is each time I get a new record, I get my reactive row and get notified for any new stock. This is my entity. This is just the data I'm working on. And I will just get notified I get something. And look at that. I can now again use skip and take like I did in the synchronous version. I don't have to do the callback L anymore. It's all simple now. And okay, so let's go back to the sequence diagram. Just say it's easy. Okay. Boom, boom, boom. So now, not only I do not wait at all, I just subscribe and get notified, but code is simple. So reactive is the best of the two worlds here. And you know what? In the latest version of the drivers, we provide you some back pressure. So when you read, if you cannot keep up with Cassandra, we will make the driver waiting for you. That's pretty nice. But when we are writing, where we cannot say the client, which is actually calling the driver to slow down because Cassandra cannot keep up, which is pretty rare because, as I said, 3,000 transactions per second and per node. Most of the time, in one node, you have 8 CPUs. So it's more or less 20,000 transactions per second and per node. So most of the time is your application that will not keep up and not Cassandra. But if it happened due to benchmark and such, we will provide you an exception, overloaded exception, pretty clear. And so, reactive, simple and not blocking, scalable and maintainable. Now, you can do some unit tests. The driver will do the magic for you just to get the record when they arrive. It's not hard to debug anymore, but you can still get overloaded exceptions. Okay, and so asynchronous. This is all I said just before. Segregated, complex callback egg. I already said that. Now, what I would like to share with you to wrap up is first to get that demo, to get the code working on your laptop. Both Cassandra, the application, the code, anything is available. And if you would like to get some information about Cassandra, as developer advocate, we provide tons of sample applications, like this one, just reactive stuff. We have a YouTube channel, and we created a video each week, one video each Tuesday, all about distributed things in 10 minutes long. So it's not only about Cassandra, can be about graph, can be anything. And every Wednesday, we are doing some Twitch live sessions. So Twitch is not only for gaming. We have live coding some application on Twitch every Wednesday. So go, subscribe, see, interact with us, ask us questions. And yeah, we are here to answer all the questions about Cassandra. And anything about DataStax. And if by chance you are interested in DataStax, we provide an enterprise version of Apache Cassandra with support. And we try to cope with limitation of Cassandra. First, in Cassandra, by default, you cannot do full search or full search. And you can only query certain columns that are part of the primary keys anyway. In the enterprise product, you can search by any column using Apache Solr, which has been integrated in the same JVM. And we also have a graph database inside, working on top of Cassandra. And everything is available on Docker. You can play with that as much as you want. And if you reach some limitation of Cassandra, go ahead and give it a try. Thank you. Yeah, sure.
How do you, Cassandra deals with data consistency? The bigger the ring, the more replication you have when you put data in. The more difficult to delete this data because you can delete some of them while other nodes have this data. And you can accidentally hit the node with the data and get totally wrong information about the information.
OK, that's a really good question. So first, you can have 1,000 nodes in your ring and a replication factor of 3. That means the data is available 3 times, even if you have 1,000 nodes. So when you have to delete something, you will only delete the data X, where X is a replication factor. Then, let's say I got a replication factor 3. I read with quorum. That means I will ask for 3 nodes to answer me. I will compare all the timestamps, and get the majority. So 2 of them will have the latest version. Okay? Just for read. If I do the same for write now, I always have 2 nodes over 3 that have the latest version, for sure. So if now the read consistency plus, which is do 2 over 3, plus the right consistency, which is 2/3. 2 plus 2 is 4. When the consistency level is bigger than the replication factor, you are strongly consistent. You are sure to have always the same, the latest version of the data when you read or when you write. So there is no issue about when I read, I am sure to have the latest version of the data, or anybody does write at the same time. No, there is no risk.
What about deleted data? I delete it in one node. It has to be replicated. And there is time for replication of this deletion.
Look, when I delete, I ask the 3 nodes at the same time to delete, right? Because from that node, the order to delete will come all the 3 nodes at the same time, right? They are not communicate. There is no transaction. I'm totally.
So this communication is very fast.
Yes, it's fast, but there is no communication here. So
of course, I understand. If you have thousands of nodes in the ring, and you delete it in one, and your replication is 500.
Oh no, replication factor is very small. 3 is a node. Replication factor is only used to ensure high availability. If I lose 1, 2, 3 nodes, I don't need to go to a replication factor more than 5, even on hostile environment. 3 is all right. And I go for a delete. Go put the delete order on the 3. By the way, in Cassandra, it's append only. So there is no real delete. It's just another line telling that this data should be deleted.
All right, thank you.
Now, but the delete order got it here. You will get 2 at least of the 3 nodes telling you, yes, data is deleted. Otherwise, client is still waiting. And if at the same time somebody come here and read to get that data, it will ask to read 2 over the 3. And it's not possible because 2 over the 3 have the delete. So, yeah, that's strongly consistent. But yeah, just for the question, we got this before about, if you want to do some semi-transaction stuff, in Cassandra it's possible. This is what we call lightweight transaction. It's not well known, but it's possible. If you put your partition key, let's say the client ID, you can write some queries, say insert if not exist. It's possible, only if you provide the partition key. There is a way to do it even in Cassandra. 99% should be done with tunable consistency, because most of the time it's working. But if you really need some transaction and lightweight transaction, you can do it.
Okay.
Thank you.
Do we have any other questions before we move on?
Just a really quick question. How do you manage querying, and when you're joining multiple tables, is it quite efficient with doing those joins?
None at all. None at all. There is no joins in Cassandra. If you have, let's say, groups and users, multiple users per group, multiple group per user, then in Cassandra you will have to create 2 tables. Most of the time it's one tables per query. It's not a big deal to duplicate the data because it has been built for huge volume. So if I say, give me all the groups for my user, I will have a table named user by group, and I will provide the user ID and get the list of the group. And if now I need to get all the users from a group, I will have a second table named group by user. And then I will provide the name of the group and get the list of the user. 2 different tables, there is no join.
Okay. How do you manage the consistency then? Between
the 2?
Yeah.
There is a way to handle consistency when you insert in multiple tables the same data. It's called batch update. We ensure atomicity, but it's not a real transaction. But we ensure atomicity. And if you execute using strong consistency, well, you're pretty sure to get the latest result, even if 2 tables are not in sync.
Okay. And one last question on your debugging, when you were talking about using Reactive.
Yep.
What's the approach? how do you get around some of the challenges?
The same way of GUnit 5 does. I didn't write the driver myself, but basically it will catch for you and make it blocking for you, because GUnit is blocking, and it will catch that for you and provide you the callback and make you wait on the callback. So you will get multiple breaking points per callback, basically. But yeah, you cannot do some breaking point in the chain of multiple callback. You will get blocked in the callback. You just put the breakpoint.
Perfect. Well, I think if there's any other questions, DataStax are over here. They're giving away some T-shirts, which are being waved over there, and some other swags. So please,
stickers.
Please go over there and see them. We also will be serving the beer and pizza outside shortly. So grab your free T-shirt and go and enjoy a beer and a pizza. But just before we go, just a nice round of applause for Cedrick, please. Thank you.